So as you might have already noticed from version 22, there has been some major changes in ANSA related to meshing. A complete redesign of the meshing layout has been introduced, while numerous new functions for mesh generation and modification have been implemented. Our goal was to boost productivity and improve user experience. In this webinar, we will have a look at the new functionality and the suggested way of working with it. Let's start with a view of the classic ANSA meshing layout of versions prior to version 22. There were 113 buttons in cell mesh, and almost half of them are hidden in the buffer menu, while in volume mesh there are 48 more buttons for a grand total of 161 buttons. Furthermore, a lot of operations require the user to use buttons from different modules, causing unnecessary delay or frustration, since quite often the user has to go back and forth between mesh and volume mesh modules. Most of the buttons are always visible, and many of them belong to functions that are not needed in most everyday tasks. Here we can see the buttons that are most frequently used on everyday meshing jobs. You can see that only a small fraction is actually needed. The buttons were grouped according to the entities that they affect. So for a specific process or task, in example, mesh and improve of a macro area, the various buttons are scattered and sometimes difficult for the user to locate them. For example, if I want to initialize the geometry and then mesh and improve the result of it, I have to press 8 buttons located in 5 different submenus. Closing, since the majority of the buttons have a single purpose, like one button, one function, there is an extensive mouse traveling between the drawing area and the function buttons. Having all these downsides in mind, starting in version 22, the mesh layout was redesigned in order to boost user productivity. Grouping of the various functions was done from the beginning, based on specific workflows. Scattered buttons and functionalities were merged under fewer buttons. Obsolete or rarely used buttons were moved to the second level. And last, but definitely not least, new direct functionality was widely introduced. Let's take a closer look. In order for the users to have a smoother transition to the new layout, the old layout was maintained, while new toolsets have been introduced based on the major meshing workflows. These are gathered under the drop-down menu of the mesh. A new toolset was created for each workflow. A toolset for cell mesh, for middle mesh, for tetrahybrid mesh, etc. Let's have a look now on how the functionality was merged under single functions. All the functionality of these existing 9 buttons can be found under only 2 buttons. Creation of mesh and resetting of the model is done by the mesh and reset button. All options are still available inside the option list, accessible when you activate each function. Obsolete functions reorganized and moved to the second level of the interface. All hot point, macro area, nodes, and mesh manipulations are incorporated under the new direct edit functionality. Please notice the amount of scattered functions that have been replaced by the new direct functionality. Finally, this is an overview of the new toolsets available. As you can see, there is a dedicated toolset for each mesh workflow. Common functions and groups are in the same position. New direct functionality is available for all toolsets at the top, while only the necessary functions for each workflow are left on the first level. At this point, let's switch to ANSA and continue there. We will start with a detailed review of the new toolsets and explain in detail the new direct functionality. Since our time today is limited, we will start with cell mesh and then continue with the creation of the middle mesh for casted parts. During the webinar, we will also suggest you a number of tips and tricks for improving your productivity using our new functionalities. Now let's move to my ANSA. I have some models ready, and let's have a look on how we can mesh a part in the new ANSA version 22. Allow me to move this WebEx window, I'm sorry. So all the previous existing functions for mesh generation are gathered in the new cell mesh toolset under one and only button with a function called mesh. With a mesh function, the user can select the area of the part that it wants to mesh, accept with a middle mouse button, and simply mesh it. All the options about the mesh and its quality are obtained from the global mesh parameters and quality criteria. The mesh function comes with different options when it comes on the level and the way that it will mesh the model. For instance, here, if I change these options, all these options are available in the options list. If I choose the macro perimeters option and I mesh the area next to the one that I meshed, I can see that the joining of perimeters is allowed where needed. The visibility of the joint perimeters can be turned on from the corresponding button here and can be seen in my model with the orange color. The model can be reset with a new reset function, which can be used to erase the mesh. Similarly to the mesh function, the reset function has also different options about the level and the way that it will reset and initialize the model. Here I just erased the mesh, but I can select the macro perimeters option to release any previously joined perimeter and return my model to its initial state. The mesh function is usually used to mesh and adjust specific areas of my model. If I want to mesh my whole part, the suggested way is by using the batch mesh. In the batch mesh, we can create a mesh scenario, add as contents one or more parts that we want to mesh, set the mesh parameters such as the element length and the minimum target length, set also quality criteria that ANSA will take into account for generating the mesh, and run my scenario. The batch mesh allows for the user allows for feature recognition and feature treatment according to the options set it from the user in the mesh parameters, allows the user to create more than one scenarios and add to them more than one part in each scenario. What is more, when we're running different scenarios, we can have them run in parallel in different cores of the CPU. After my job is completed, before closing the batch mesh, it's important to remember that since most of the actions that we do, or most of the functions of ANSA work with the global mesh parameters and quality criteria from the global settings, it's important to copy my mesh parameters from this specific batch mesh session to my global settings, simply by right-clicking and selecting Copy to Global Settings, both parameters and quality criteria. Now I will close the visibility of the joint perimeters to have a more clear view of my model, and allow me to focus on an area here to demonstrate to you how the new direct edit functionality works. The direct edit functionality gathers all the functions that are used for mesh improvement and manipulation under a more interactive and direct function that is divided in two main categories, the element categories and the areas categories. As we saw, the direct edit functionality is entity dependent. That's why it's divided in two main categories. You can activate the direct edit functionalities either from the top right area of the function list or with a shortcut that can be set from the user. I will activate it from here now, and I will start by demonstrating the elements category. When we have the direct edit functionality active and I hover my mouse over my model, I can see a preview of the action to be performed. This preview, it changes depending on the entity that I hover over. To have a clearer view of the direct functionality, we have the function assistant or the information window on the bottom left corner of my window that I can activate it by clicking this eye. The function assistant contains a brief overview of all the functionalities and all the entities that are available in the elements category. I can see that with the elements category, I have access to nodes, edges, or elements. And over each entity, I have access to different functions. More functions or options are hidden in the context menu that can be activated with right mouse clicking. Every function that exists in the context menu of the right-click menu has its corresponding shortcut key from the keyboard that can be seen here in parentheses. I can navigate through the different functions available for each entity, either through this context menu here or with the shortcut key tab that I will use from now on. In the function assistant, we can see also that different mouse actions like click, drag, or control-click actually prompts different functions. For instance, if I come here and I grab a node and drag it, I can move it on the surface. Switching to the other available function for nodes, I can drag a node to move it normal to the surface. Finally, clicking on a node, the node returns in its origin. By dragging a node onto another node, I can perform a paste. Changing now to the edges entity, I can see from the preview that when I hover my mouse over an edge, I can perform a split by clicking. If an edge is splitting a quad element, I can hover my mouse over this edge, click to perform a join. Finally, when I'm over an edge and I can switch to the other function available with the shortcut key tab, I can see the preview that informs me that I changed the functionality, and by clicking, I can perform a collapse. Now, when it comes to the elements category, I can see from the preview that on quad elements, I can perform either a split or an XSplit, switching again with the shortcut key tab. Allow me to undo by Ctrl Z this action. Then, by hovering my mouse over a tria element, I can see that the element is getting highlighted. And that's because if I drag it, I can move the element, the tria element, on the mesh. You can notice that after every move of the tria element, the mesh around it is redistributed because the improve function of smooth is applied on it. This is because I have activated it through the options list here. You can see on the bottom right of your screen. I have active the smooth function. Allow me to make it a bit bigger. Every time I move a tria. Other options is to have it always on, like after every mesh action, or never. I will leave it now on after I move tria and come back to this tria here. More actions that I can perform with dragging a tria is that if I drag the tria to the edge of the model, I can remove it. Opposing trias can be dragged on top of each other to completely eliminate it. Going back to my context menu by right-clicking here, I can see that I have access to a function called Mesh Brush. I can activate this either through the context menu or with the shortcut key B. Here, with the Mesh Brush, I can see that we have a direct brush, an interactive brush tool, which contains all the previously existing improve functions in it. By right-clicking, I can see that I have here the reconstruct, the smooth, the fix quality, and the origin. I can navigate through these functions also with the tab key. I can decrease the size of my brush or increase it with the shortcut keys 1 and 2 from the keyboard. By clicking and dragging over my model, I can apply an improve function to the areas that I want. Of course, we didn't lose the traditional, let's say, the already existing improve functions that I can find it here on the functions list under the cell mesh, in case that the user wants to improve the whole model or a specific macro area and in general. Going back to my context menu, I can see that through it, I can switch to the other category of the direct edit, the areas category. Or I can use my shortcut from my keyboard, the shortcut key Q. When I have activated the areas category now, I can see in the function assistant that I have access to perimeters and hot points. By hovering my mouse over a perimeter, I can click to add a hot point. Dragging from a hot point to an opposing perimeter, I can perform a cut. Or always there is an option to follow the path of the edges of the element to perform an edge to perimeter. When I have my mouse over a perimeter, it gets highlighted, and by clicking on it, I can perform a join. After every mesh action on the mesh while on the areas category, the improve function of reconstruct is applied. Again, this can be activated or deactivated from the options list here that I have it active, that I can see it with this click. If I want to join multiple perimeters at once, I don't have to click every one of them. Instead, I can go on the context menu here. I can select join multiple, select with my mouse more than one perimeters, accept with the middle mouse button, and simple as that, I joined more than one perimeters. Already joined perimeters can be seen when on the areas direct edit category with the orange color again. And when I go my mouse over it, I can see that it gets highlighted, and by clicking on it, I can perform a release and bring the perimeter back to my model. I can change the position, let's say, of a perimeter by grabbing a node on its edge and dragging it on another perimeter, like here, or even not paste a node, just move my perimeter to the side. Here I can see that this feature, this stamp on my model, after the improve reconstruct got applied, lost its original mesh. And if I check around it and I can notice that I have similar stamps to this, and I would like to have the exact same mesh to this stamp as well. In order to avoid doing the remeshing on my own again, all the actions needed, and also be sure that I have the exact same mesh in similar stamps, the direct edit functionality comes in use again. By changing to the draw mode, to the feature draw mode from the menu here on the bottom, I can see that all my features are colored here. This is because they got recognized through the batch mesh that I ran earlier. So with the purple color, we can see the recognized stamps, or with the blue color, we can see the recognized fillets that are entities, feature entities. The direct edit functionality is specially adapted to be able to give me a direct access to the feature entities as well. When I hover my mouse over a feature entity, like this stamp here, I can see that it's highlighted, and that means that with the direct edit functionality, I have direct access to it. By dragging from this stamp and moving to another stamp, similar stamp, I can see that I can perform a copy of the mesh. I'm sorry. If ANSA manages to identify these stamps as similar, and I release my mouse, I can see that momentarily the stamp got colored green, and now, which meant that the features were recognized as similar, and now the mesh was copied successfully, and now I am sure that I have the exact same mesh on similar features. The direct edit functionality gives me also access to more direct access to more features, like fillets that I can see here. Again, when I go my mouse over the fillet, I can see that it highlighted, and that means that by clicking, I have direct access to its treatment, and I can define it. For instance, here I can say that I want 2 rows on this fillet. I can click OK, and instantly I can see that in this fillet I got 2 rows of elements from edge to edge. Also with the direct edit functionality, I can see that I can manipulate 2D holes that were recognized from the batch mesh, and by clicking on them, I have direct access again to the 2D holes treatment, and I can specify, for instance, here that I want a washer zone with a 2 millimeters width. I can accept with an OK, and I have my desired mesh treatment around the feature. All these modifications that I did, of course, can be seen in the feature manager here. The feature manager contains all the feature entities that were recognized through the batch mesh. And if I can see here that I have the treatment that I specified directly through the direct edit functionality. And from now on, every change that I make in my model, in the mesh of the model, it will respect this treatment that I set it through the direct edit functionality. Now let's combine all these things that we saw to try to fix a messy area. Let's say, let's improve the mesh of an area using only the direct edit functionality and keeping the focus and our mouse and the focus on the middle of the screen. Now I have the direct edit functionality here on the areas category, and I will try to fix this area here. I will perform a lateral cut here, dragging from this node to have a more uniform mesh. I will start by fixing these stamps here that I want to have a more uniform mesh and also to be symmetric in the Y and X axis. I will start by performing 2 cuts here to help the mesh be have a better flow here. Allow me to move a bit my model. I can come here. I want to have less elements, less nodes in this perimeter. I can open the right-click context menu here, and I can see that I have direct access to the nodes number. I can either decrease or increase the numbers here, or with the shortcut keys 1 and 2. I will decrease by 1 node here, and I will do the exact same on the other side to be sure that I have a symmetric mesh, but this time I will use just the shortcut keys from the keyboard, the shortcut key 1. Now I can see that in these areas here, from 2 rows of element, I have only 1, and I want to increase it. I will switch to the elements direct edit category now with the shortcut key Q, and I see that I want to perform a split here, but I want to perform it through the other edge. By holding the control key down, I can click and perform a multiple split in more than 1 element. And then I will also easily join this quad. I will do the exact same process on the other side here. I will join these elements. Finally, I want to fix a bit this area here to remove some triangles and have more quad elements. I will switch. I hover my mouse over this element. To perform a split, I will switch with the tab key to the X split, and here the same, and I will join these elements. And finally, I will call the improve brush that we saw earlier with the shortcut key B. I will leave it on smooth. I will increase a bit the size, and I will smooth the mesh around this feature. And you can see now that I have a perfect mesh on this feature. It's symmetric. It has as less triangles as possible. And I can see now that this feature here, this stamp, is similar to this one. As we saw earlier, we don't need to do all this work again for a second time. I can simply switch to my feature draw mode, switch also with the shortcut key Q to the areas category, and I can simply drag and drop this mesh to copy it to this feature. I can see that it got colored green momentarily. That means ANSA recognized the features as similar, and I am sure now that I have the exact same mesh on these two features. Now we'll focus on this area with the fillets and try to join these perimeters. I will join multiple, select all the perimeters that I want, accept with the middle mouse button. I will release also this area here. And I can see here that I don't like this mesh. I will simply reduce the nodes of this perimeter with the shortcut key 1. And simple as that, I have my mesh nice. Now I will end up by fixing this area here. I will try to remove as many triangles as possible, fix the flow and the quality of this mesh here, and have as many quads as I can. I will start by removing this triangle, moving it to the edge. Here I can eliminate some opposing trias like this one or this one. These trias, I'm gonna move them to the edge to be gone from my model. I can see here also opposing trias here as well, and here as well. I will remove also this. I will send this to the side all by drag and dropping, and I will also send this away. I can see here that after I performed this joining of the triangles, the mesh became too fine for my mesh. That's okay. I will switch with the tab to the collapse function. Again, I don't have to do it one by one. I will hold down my control key, click, and perform a collapse in a path. Yes, I like this more. And I can see now that I did my best here. I will bring again my brush, my improved brush, increase a bit the size. Also, I can see here that some nodes are off the perimeter, and I don't like that. I will switch through the function with the tab key. I can see now that I'm on the origin. I will decrease the size a bit. I will apply it here, and now I can see that my nodes came perfectly to this perimeter. I will increase my size now, and I will perform a smooth after I finish to be sure that I have a smooth result. And simple as that, you saw that we fixed an area of the model. We removed triangles. We fixed the mesh of stamps. We have the similar mesh here. And all this, we did it simply by keeping the mouse in the middle of the screen. With the mouse, we kept our focus in the middle of the screen. We didn't have to travel excessively to the side of our screen. And we fixed this area. We improved the mesh of this area very easily. That was all about the mesh. Now let's move to the second topic that we will see today, the middle mesh. So similarly to the cell mesh toolset, there is a dedicated toolset for the extraction and manipulation of middle mesh from a 3D geometry. It is called middle mesh, and it can be found also from the drop-down menu from here. The previous existing tools for extracting the middle mesh from a 3D geometry, the casting and the extrusion, are combined and renamed under one function called generate. By hitting the generate, we have the options window open, where we can define whether we want the casting or the extrusion algorithm to run. We are setting also the mesh parameters for the mesh to be generated, and also the user can apply here a feature recognition or treatment for the features that he wants. I have already run a casting on this model. and we will start by showing the result. The casting algorithm gives to the user an FE result that is disconnected from the geometry, but associated with it and linked through entities that are called align constraints. To check the validity of the result, the new inspect function comes in use. The inspect will compare the result to the initial geometry based on some criteria and limitations set by the user from the options list. I will select now my model, accept with the middle mouse button, and have the inspect run. The inspect will mark the areas that needs correction and color them according to the error that they present. The explanation of the coloring scheme can be found here on the legend. Also, the visibility of the result of the inspect can be turned on and off again from the legend here. Knowing in which areas now to focus, I will start by fixing the result of the middle mesh that the casting algorithm gave me. All the directed functionalities that we saw earlier works also with the middle mesh. They are specifically adapted to be able to manipulate entities that are called align constraints that are the result from the casting. When I have the directed functionalities activated in the areas category and I hover my mouse over the model, I can see here these colors that they're actually the preview of the align constraints that associate the macro perimeters to the underlying geometry. Here we can see two different types of align constraints. The red colored areas have the align constraints of plane, which actually positions them in a plane that is defined from two different faces of the geometry, can be seen here with the blue color, and the green colored macro areas are associated with the geometry in the middle of between two faces, even if these faces of the geometry, of the underlying geometry, are curved, like we can see here. To have a better view of the constraints that are defining an area, we can, by hitting Control and Shift, we can hide the shadow of the model and see it in a transparent way to have a better image of what's happening underneath my model. Here I can see that this area doesn't look correct. And if I turn on the geometry to compare between the FE result and the geometry, I can see that this area has a lot of fillets. It's a bit complicated, and that's why I have these align constraints here. By hovering my mouse over this specific area here and hiding again the shadow, I can see that this is the desired align constraint for the rest of the areas. I can add an area to an align constraint simply by dragging and dropping to the desired align constraint, as you can see here. After I perform every action on the mesh, I can see, apologies for that, I will Control Z, I can see that the constraint is automatically applied. This is because I have activated again from the options list here in the bottom right corner that I have the auto apply constraint after every mesh action activated. I will continue doing the same on the other side of the cylinder, but this time instead of dragging one by one all these macro areas, I can select them all together by holding down the control key from my keyboard and clicking on them. I can see that I selected more than one and drag them to the desired align constraint. And simple as that, I can see that I can fix my result. I will continue doing that. I will add them to the desired align constraint. And simple as that, using only the direct edit functionality, again, I fixed this area of the cylinder. Now I will proceed by fixing this area that the ribs are coming and get joined. I will switch to the elements category of the directed functionality. Again, we saw earlier that we can do this very easily with the shortcut key Q from my keyboard. And I will start dragging the nodes to paste one on each other here to fix my result. Here I can see that after I perform this action, again, the align constraint was automatically applied. I will continue doing to paste all these nodes. And now I've been left with some perimeters that need joining. I will switch to the areas category again, and by clicking, I am joining all the perimeters that I want. I have one more hidden here. And in this case now that I will join a perimeter between two areas that have different align constraints. The two constraints, we can see here that this has this plane and this is between these two fillets, let's say. If I join, the two align constraints are merged. We can see here the preview. It's important to remember that the align constraints not only constrain a macro area about its position, but also gives to the macro area the information about the nodal thickness that it should have according to the geometry. I can have a preview of the nodal thickness of an area by drawing my cells as solids here. I can see now that these two areas that got their align constraint merged doesn't have the desired nodal thickness. And I can see that by comparing it to the geometry, I can see here that these areas are thicker. Let me close the draw cell as solid. This is because they have also in their align constraint this definition from the fillets. I can edit the align constraint of a macro area by accessing through the right click to the context menu and saying here change constraint, edit, but I can also activate it with the shortcut key E. By editing the constraint, I will remove the unnecessary constraints here with the right click of my mouse. I will do the same here. I will accept, and I will do the same here, but this time I will just activate the edit constraint with the shortcut key E. Again, by right click, I remove the unnecessary definitions, accept with middle mouse button, and I can see now that they have the desired align constraint. And if I draw the cell as solid, I can see that the nodal thickness was updated, and now it's exactly what I wanted according to the geometry. Now I will try to make this the mesh of this tube more uniform. I can see that I have some hot points that are not needed. I will select delete multiple here from the right click menu, box selection, accept with the middle mouse button, and simple as that, I deleted all the hot points that I didn't need. I will come here and I will try to fix the sides of the tube. I want to have here a four-sided mesh. I have access again through my right click menu to the pattern mesh. I will select here the four-sided. I will select here the map opposite sides, and I can define the number of the nodes. Here I will do the same on the other side of the tube, hitting the shortcut key V this time, again giving 3 nodes, hitting finish, and simple as that, I can continue fixing this result. Now let me focus on another area of the model here to show you that if an area doesn't have an align constraint, it appears as with this brown color, and it's characterized as empty. I can set a constraint to an area by setting a constraint here from my right click menu. This time I will set a plane constraint, and I will define a plane through these two faces. I can see a preview here with the purple color, hit accept, and now this area has an align constraint, and also if I draw the cells as solid, I can see here that I have the desired nodal thickness as well. I will go now to the other corner of the model to show you that as the macro perimeter have the align constraints, also the perimeters have their own align constraint. We can see here with the red color, the faces align constraint that constrains the perimeter to be on top of this face. And also with the green color, I can see the imprint align constraint, which is actually imprints a perimeter from a perimeter of the geometry. Here we can see an empty perimeter, which doesn't have an align constraint. And if I turn on the geometry and compare it, I can see that it doesn't come to the end of the face. I can set a constraint to this perimeter. I will select the faces here, accept, and now if I turn on the geometry, I can see that it's exactly where I want. I can set an align constraint for multiple perimeters at once by holding down my control key. I will select all the perimeters, change constraint, and I will imprint these perimeters. At this time, I will select to be imprinted between this perimeter and this one here. Hitting accept, I can see now that I have the correct definition. Now I will turn on again the visibility of the inspect result to see here that I have this red color, and if I turn on the geometry, inspect informs me here that I have a missing mass. This happens because I don't have this cylinder on my FE model. I can very easily create this cylinder with the solid mesh O junction function that can be found here, which will automatically detect the cylinders that it can mesh and gives the user the option to mesh it either as solid, either as cells with cap or cells without cap. I will select here the hexa solids. I will hit finish. And I can see here that I very easily have a solid mesh of my cylinder with a perfect pattern on the top. Finally, now that I'm finished, I will run one final inspect to be sure that I didn't miss anything. After the inspect is run, I can see that an error remains here. I cannot locate it with my eye. I can focus on it by right-clicking and select it show only here, and I can see that it's this small area that I missed. I will activate again the direct edit functionality from my keyboard shortcut here. I will add this constraint to the correct align constraint, and if I update my inspect, now I can see that no error remains. Following the same workflow now and making use of the direct edit functionality, the user can proceed to fix a more complex result very easily. For instance, here I have an example of a model that I already invested some effort and time to fix. You can see here that it got a lot of complex areas, some tubes that needed solid mesh. We can see here the mesh pattern, it's perfect. All these tubes have a nice mesh and the correct align constraint. This bulky area also, all these perimeters are defined correctly. And in general, it's a model that I invested some time and effort to fix and have the perfect middle mesh from my 3D geometry. But what happens if an updated version of this model comes, which is similar, but still has a lot of differences? Not a lot, but quite some differences. Do I have to do all this work from scratch and all this to create all these tubes and all these similar areas? Spoiler alert, the answer is no, but first we have to identify and locate these differences, and we can do this with a compare tool, which allows the user to import the updated geometry here. ANSA will compare these two geometries after running from some seconds, and it will give as a result to the user the two models in parallel that can be manipulated in parallel. They will open here with a compare tool in two separate windows. I can see here that every move that I make on the updated version, it will happen also in the previous version. With that, the user can perform a visual inspection to identify the differences, or the user can activate the smart navigation here, which actually opens the two models and colors the areas that are found different. Here we can see the one on top of the other, and we can see here, for instance, that this area is colored because the flange in the updated version got wider. Or for instance, this tube here, it got moved 2 millimeters to the side. This bulky area was completely removed in the updated version, etc. Now, I don't have, as I told you before, I don't have to do all this work from scratch. ANSA gives the user the ability to run the casting algorithm here from the middle mesh menu. If we go to the generate options menu, now I have my updated geometry here. Gives the option to the user to activate here this option that is called inherit, and insert here as input the previous model that I already fixed the result and it's ready, and run the casting algorithm with that option. After this, the algorithm runs, I have already run it and I have here the result. The result will look like this. Don't get scared with the coloring here. The blue color is actually good news, is all the areas that were recognized as similar between the two versions of the model, and they got inherited from the input file that we put in the generate options list. So they are colored blue to inform the user that I don't have to do any improvement work on these areas. They are inherited exactly as I fixed them in the previous version. The non-colored areas are the areas that they were recognized also that we saw in the compare tool, that were recognized as dated areas and need the attention of the user to decide what to do with them. I can come here, for instance, in this flange that we saw earlier that it got wider. If I turn on the geometry, I can see it here. And in order not to guess what I have to do, I will again activate the inspect tool, run it. I selected my whole model with Control A, and I can see here that I have the result of the inspect to know exactly in which areas to focus and fix. Here I can see that it informs that I have a missing mask because it's this flange that it got wider. I will go again to the direct edit, be in the areas category, and I will simply set a constraint to this perimeter. I will select the faces here, category, select this perimeter to reach this area, and I can see that I got my flange exactly as I wanted. And if I turn the geometry on and compare it, it's exactly what I want. I can, by right-clicking, I can exclude now this area that it's fixed. I can exclude it from inspect. It got colored blue, and I now know that I'm finished with this area, and I can proceed with the rest of the model. I will now allow me to turn off the visibility of the inspect, since I know now I saw where to focus to have a more easier for the eye result. Here I can see that this is the tube that we saw earlier, that it got moved to the right for 2 millimeters. And if I turn on the geometry, I can see that it's not in the correct position. And if I hover my mouse over it, I can see that it has the correct definition, but it's not in the correct position. I can fix that very easily. I will activate my brush with the shortcut key B again. And I have, while in the align draw mode, I have available the align function. I will increase now the size of my brush to do less moves. I will apply it here in this tube, and if you pay close attention, you can see when I release my mouse that this tube will move to the right. Now I can see here that it's in the correct position. If I turn on the geometry, is exactly where I want it to be. If I turn on the draw cell as solid, I have the correct nodal thickness, and now I have to move here. We can see here now these empty areas that are actually the areas that were existent in the previous version of the model, and the inherit function brought it here for the user to decide what to do with them. Here, as we saw earlier, this bulky area is not existent in the updated version, so I will simply select all these areas and add them to the correct constraint. I can also bring my brush here, decrease a bit the size, and perform a reconstruct to have a better mesh. Also, this tube, I saw that it wasn't existent in the updated version. I can isolate it here from the legend. I will right-click and select show only, and I will just delete it because I don't need it for my updated version, except with the middle mouse button, bring back my model. I can see here that I was left with a hole that it's very easy to close with a fill function manual. I will select these perimeters, accept, and after I do also a join here, the mesh will be reconstructed and I will have the desired mesh. I will move now to this rib here that it used to have in the previous version. It had this wavy shape, but if I turn on the geometry, I can see now that it's straight. I can simply select these two perimeters, set constraint, faces, and I will say it to be here in this constraint, and now I have my fillet ready. Finally, this new this area that wasn't existing, it wasn't inherited from the older model, but it was generated through the updated geometry. I can see that it's not connected to the original model. I can very easily connect it with the new connect function, which gives the user the ability to select the perimeters that the user wants to connect here. I have activated them. Sorry, I have a perimeter here on the bottom as well, and on the other side. I have activated as target the visible elements. I can see with the red the preview of the connect to be made. And if I accept with my middle mouse button, I can see that very easily I have this tube and the rib connected. Finally, I will do the same for this rib here using again the connect function. But if I select this perimeter, I can see from the preview that I don't like the result. I have here more options about the target, and I can select cells, which is actually the target will be cells defined by the user. If I accept the selection of the perimeter with my middle mouse button, ANSA prompts me to select cells that's going to be the target. I will select here. I can see the preview that now is the desired result. And by accepting with the middle mouse button, I have the desired result. I will do also this for the bottom area. And simple as that, I have my model ready. I will also, being on the directed functionality, I will delete this hot point to give a constraint to this empty perimeter, and I will drag and drop this to add it here. And now I think I am finished with the result, and I will prove it now by running one final inspect on the whole model. I can see here that all the errors were eliminated, and simply by fixing the areas that change between the two versions, I now have again my model ready, the middle mesh extracted and associated with the correct updated geometry without needing to do work that are similar between the two models for a second time. I didn't have to touch these tubes here that I fixed the pattern. I didn't have to to touch any other area of the model other than the area that changed between the two versions. Now I can see that we still have some time, so allow me to show you two more very interesting functions that got introduced in the Nuance version 22. So I will close this hole here, and I will delete also this fillet. And let's make now the assumption that we got an inherited result that in the new version we had a hole and now the hole is not existent, or we want to create a rib that it's not existent. And if I turn on the geometry here, for instance, we can see that we want here to have a hole, but we have elements. We can very easily create the hole from scratch using the new function called trim here. By activating the trim, I can click on my mesh, and the mesh now it's gonna get trimmed according to the geometry. If I turn on the geometry here, I can see with the red color the preview of the hole to be created, and simply by hitting middle mouse button and accepting, I have my hole. I created a hole from my mesh, trimming it to the geometry. And then if I move here, let's say that we want to create a rib that is existing in the geometry. The new middle mesh manual function comes in use, that it allows the user to generate FE elements associated with the geometry manually, either define them from side or from top. Here I will select the from side option, and I can select two faces of my model. Here, these two faces of this rib, I will give a target element length here according to the element length of the rest of the model. And if I click finish, I can see that very easily I created a rib. The only thing that now is needed is to connect this rib to the rest of the geometry. I will use again the connect function that we saw earlier here. I will select the perimeters of the rib. And again, I will change my target here to visible cells. I can see the preview that it's exactly what I want. The perimeters are extended to the side. I will accept with the middle mouse button, and with just using two functions and a few clicks, I have my rib defined from the geometry associated. And also, if I turn on again the cell as solid here, I can also see that I have the desired nodal thickness compared to the geometry. Is exactly what I wanted. So that was all from me, from my presentation. We saw in this small presentation, we generated a cell mesh on a model. We also generated a middle mesh from a 3D geometry. And we did all that mostly keeping the mouse and our focus in the middle of our screen. If you pay attention, almost 90% of the functions that we used were accessed either through my mouse, that it was on the center of the screen, or from the shortcuts that I had on the keyboards. And by that, we eliminated extensive and unnecessary traveling to the side of the screen. I think we increased the productivity and the experience. We decreased the frustration, and we had, I think, a better overall workflow.